Okay, chapter 11, areas of parallelograms and triangles. Let's do parallelograms first, but we're going to do a special type of parallelogram first just to kind of introduce areas. So this thing right here is a rectangle. I just put a bunch of squares in here, but I'll show you in a second why I did that. So I've got a rectangle. Remember, a rectangle is a parallelogram. So the equation or the formula, let me turn the volume down a little bit. The formula for the area of a parallelogram is the same as the area of a rectangle. And if you remember, when you were just a young child, I'm sure, you learned how to find the area of a rectangle. And do you remember this? The area of a rectangle is, I think when you're a kid they taught it like this, the length times the width. We're going to use a little different language right here, but it's really the same thing. So that's the area of a rectangle. Let's put that away for a second, and let's just see why is it the length times the width. Now it doesn't really matter. I remember when I was a kid I couldn't remember which one was the length, which one was the width, and I don't think a teacher ever told me it, but it doesn't really matter which one you call what. So you could call this the length if you wanted to. Whoops, I'm a little off there. Let's try that again. There we go. Okay, you could call this the length, and you could call this the width, but it doesn't matter which one. I always thought the length was the longer one and the width was the shorter one, but that doesn't make any difference at all. I could have called this one down here the width, and I could have called this one the length, and it doesn't really matter. As long as one side is one and the other side is the other, it doesn't matter which one is which. So if I wanted to find out the area, what are we talking about the area? We're talking about all the space that fills up this rectangle. That's what we're talking about when we find the area. We're not talking about the distance around it. The distance around it would be the perimeter, and we've talked about that a lot, especially in the circle chapter. We talked about circumference and things like that. We've talked about perimeter quite a bit before. So it's not the perimeter, it's not the distance around, it's all the space in here. And how do I tell how much space is being taken up? Well, we break it into squares. And so what I've got 1, 2, 3, 4, 5, 6. I got 6 squares across. So the length, we'll just call them inches, or whatever unit you want to call it. We'll just say inch. Okay, so this is 1 inch, 2, all the way to 6 inches. So the length would be 6 inches. And if you count up and down, count the width, that would be 1, that would be 2, and that would be 3. And so the width is 3. Now, just like you were going to count, like, I don't know, a row of chairs or something like that. And let's say you had a whole bunch of chairs or whatever the case is, and you didn't want to count each one individually. Look, we don't have to count every single one of these blocks individually. We can just count across, count up and down, and then multiply them together, and that tells us how many chairs or whatever there is in this situation. So there's 6 across and there's 3 down, so that means there's 18 altogether, because there's 1 row of 6, a second row of 6, and a third row of 6. There's 3 6s, and 3 6s are 18. So to find the area of this, it would just be the length times the width, which would be 6 times 3, which is 18. And these, notice, they're squares. We broke them up into perfect squares. So if it's inches, I would say this. I would say square inches or inches squared. A lot of times you'll see it like this. You'll see, like if you go, I don't know if you ever went shopping with your parents to get carpet, or you want to get flooring or something like that. Something that takes up an area. They usually sell it in square inches, or square feet probably, but we're using inches right here, so you could see it as square inches. A lot of times you see it like that. It's exactly the same thing. Notice I'm not squaring the 18. It's not 18 squared. You're only squaring the inches because it means there's 18 squares, and each one of these squares is 1 inch by 1 inch. So that's what they're talking about right here. Well, I've talked about length and I've talked about width, but when we are going to talk about this with parallelograms and triangles, we don't use the word length and width anymore. Okay, what we're going to do, and let's get rid of some of this stuff. Keep that little brace thing there. What we're going to do is we're going to call one of them the base and the other the height. Okay, base and height. So B and H for base and height. And this is going to be just to make us a little more consistent. So we can use it for triangles, and we can use it for parallelograms, rectangles, squares, any of those things. We're going to use base and height, but it means the same thing. Does the base have to be the one that's on the bottom right here? No. Does the height have to be the one that's going up and down? No, it doesn't. It doesn't really matter which one you call. the base or which one you call the height. But there is something that's really, really important to this. I made this a rectangle just to make this kind of easy for us. But what do we know about a rectangle? We know a rectangle forms 4 right angles. So all 4 of these places are right angles. So if you notice this, the height is perpendicular to the base. Now that's really important right there. The height and the base being perpendicular is really, really important because the base and the height are always perpendicular. So if I looked at a parallelogram or a triangle or anything like that, the base and the height must always be perpendicular to each other. So let's do a, I'll tell you what, let's just do another rectangle. And I don't know, we'll just make it look like this. Okay, so here's just a regular rectangle, and let's say the length of this was 10 and the length of this was, I don't know, 4. We'll just make it really easy, and I asked you to find the area of this rectangle. Now remember, it's a rectangle, so the base and the height must be perpendicular to each other. It's very important that I know that they're perpendicular. So it's very simple. You just code 10 times 4, which is 40, and then whatever the units are, let's say it's in feet this time just to make it a little different, so you'd say feet squared. So 40 feet squared, or 40 square feet, a lot of people would say. That's how you find the area of a rectangle. Pretty simple. All right? Let's do a parallelogram, and things might be a little bit different with a parallelogram. Rectangle's pretty easy because you know they're already perpendicular. They usually give you the height and the base, and then you can find the area very easily. Let's do a parallelogram now. Okay, here you have a parallelogram, but if you notice, it's not labeled, so let's do this. Let's call this bottom one right here, let's call this the base. I'll tell you what, we'll just put B for base. All right, this is our base. So now which one is the height? A lot of people would say this length right here is the height, right? Because it connects to the base. But remember what we said about the base and the height. The base and the height have to be perpendicular to each other. Is that a right angle? No, it's not. Okay, and how do you know it's not? Well, because they didn't tell you. They didn't put the little box thing right there. Okay, you can't just always go by how it looks, but they didn't tell you. So that's all the information they tell you. You don't know what the height is. So where would the height be? Sometimes they tell you the height. Sometimes you're going to have to figure it out. We'll do an example here in a second where we're going to have to figure it out. But watch this. This right here would be considered the height if they put a little box right there. So if they put a little box there, that would be the height, because watch what it does. It goes from the top, okay, and perpendicular to the base. That's the height. So if you know those two, then you can find the area of this parallelogram. So the area of a parallelogram is the base times the height. We'll just put BH. It's just like a rectangle, except sometimes they don't give you the height and you got to figure it out. Again, we'll do that in another example. But that's how you find the area. All right, so let's say the base of this. Let's say from here to here, and this is again very easy, just as easy as far as the math is concerned. Let's say, I don't know, I'm just making it up. Let's say this is 8, and let's say the height right here, actually, let's do this. Let's say it's, I don't know, 4. So the base is 8 and the height is 4. This is what they give you. It's a parallelogram, and you just multiply them together. So 8 times 4 is 32, and that, and whatever, let's say centimeters this time. So it's centimeters squared, and that would be the area. And again, what are we finding? It's like this. It's like if we would have broken this up into a whole bunch of squares. If we would have put a square, you know, 1 centimeter by 1 centimeter square all inside of here, how many squares would fill up this parallelogram? Well, there'd be 32 of them, right? That's what you're really finding. You're finding out how many squares, 1 centimeter by 1 centimeter squares, actually fit inside this whole thing. And there'd be 32 if you could do it. Now you notice the squares, you might like have half a square along here, half a square here, but if you add them all up, they'll eventually add up to 32 of those squares. Now let's do an example that's not quite as easy as this, because you understand, I mean, it would be nice if they were all this easy, but you understand it's not always going to be like that. So let's take a look at more of a realistic example of what we're going to be doing. This first example, they're starting off pretty easy, so let's see what we can do here. They actually asked you to find in this example, this is from the book on page 764, it's example 1, and they asked you to find 2 things. We mentioned perimeter a second ago. They actually ask you to find the perimeter. That's not all. they ask you to find the perimeter, and they ask you to find the area. I'll just kind of split it up like this. Okay, so let's do the perimeter first. Perimeter is pretty simple. Perimeter is the distance around the whole thing. Okay, if you just add up all four sides to this parallelogram, you've got the perimeter. So let's take a look at the four sides. This side is 10. If it's a parallelogram, which it tells you it is, okay, they tell you in the instructions that this is a parallelogram. So if this is 10, the opposite side must be 10 as well. The bottom of this, the other side of the parallelogram is 4. So up here, this must be 4 as well. So you just add them up. I got 10 plus 4 plus 4, that's 28, and so it's just 28. It's in inches, so it's just inches. It's not inches squared, because we're just finding the distance around the thing, so it just stays inches. The perimeter just stays inches or centimeters or feet or whatever you're using right there. So it's just 28 inches. Let's find the area, though. The area, remember what the area is. The area is the base times the height. And the key to this is understanding that the base and height have to be perpendicular to each other. So if you're looking at this, they give you several different numbers all over the place. You have to figure out which one is the base and which one is the height. That's really the hardest part of this. The actual multiplication is easy. It's figuring out which one is the base and which one is the height. Well, it's always the ones that are perpendicular to each other. So find what sides are perpendicular, or what lengths are perpendicular to each other. Well, I've got a right angle right here, so I've got to have something perpendicular. Well, this BC, this 10 right here, could be the base. What would the height be? Well, it's the side or the length that's perpendicular to that 10. And this 5 right here is perpendicular. It's not the 4. It's the 5, because the 4 is not perpendicular to BC. This 5 is. This D whatever letter, I think they put an E right here. I forgot to put that in there. Okay, so DE is perpendicular to BC, so that is your base and your height. It doesn't really matter which one you call the base, which one you call the height, because you're just multiplying them together anyway. So it's just 10 times 5, and that's 50. Now remember, this is in inches, so it's inches times inches, right? So this is 10 inches times 5 inches. What's inches times inches? That would be inches squared, or square inches, and that's how you find the area. Pretty simple, as long as you know which one is the base and which one is the height. Now again, that was a pretty easy one. They made it look a little different than when we first did it, but as long as you know which one is which. They gave you both. They gave you the height and they gave you the base. Just multiply them together. In this next example, you're going to have to do a little bit of work. You have to remember something from the past to be able to find the base or the height. So let's take a look at that one. Okay, here it is. This is where they're asking you to find the area of this parallelogram. Notice they don't tell you the height. They call it h, all right? So you know that's the height, and you know it's the height anyway because it's perpendicular to the base. So your base would be 15. So your base is 15, and your height is unknown. So what you have to do is you got to figure out what the height is first, and then you can multiply the 15 times whatever the height is. But look what they give you right here. You know it's perpendicular, okay? So you know you have a right angle here. This is 45 degrees. So what else? You know that this is 45 degrees. It may not look like it because it should be a isosceles triangle. This length and this length should be the same. They don't really look like they are, but we're just going to go by the numbers, okay? It doesn't have to look like it as long as the numbers are right. What do we remember about a 45, 45, 90 triangle? We remember that the hypotenuse is equal to the square root of 2 times one of the legs. That's something you need to remember. What do they tell you? They tell you the hypotenuse, which is 8.5, is equal to the square root of 2 times one of the legs. We'll call the leg h this time since that's our leg. And so how do you solve for this? You divide by the square root of 2, and that's what the height is. So we can actually put that into a calculator, and or you can just keep it. I tell you what, let's just keep it. It's kind of weird to keep it like this, but it'll save us some calculator work. 8.5 divided by the square root of 2. So we'll just keep it like that. And then, now we know what the height is. And now it's really simple to find the area. So if I want to find the area, it's just the base times the height. So it's 15, I'll just put this over 1, times this height. Now it's kind of crazy looking. I guess you could have put it into a decimal right here if you wanted to. Or you could just put all this into a calculator right now. And I'm not going to show you how to do that. You should be able to work that thing out. And let's see, it comes out to approximately 90. Alright, so put this into a calculator. 15 times 8.5 divided by the square root of 2. It doesn't come out exactly, but it comes out approximately 90. Now, this was in millimeters, and it's area, so it's millimeters squared. I'm not going to be really picky. counting off if you don't put the units, but in some courses they will. Like I taught physics for a lot of years, and I would take a point off if they didn't put the correct units. Okay, in the real world, if you want to call it that, units are very, very important. So try your best to put the correct units here. That's how you do that. Okay, so that's a harder version, I guess, of the area of a parallelogram, where you have to find one of them, and you have to learn. You have to go by some stuff that you knew before. They might have not given it to you as 45. You might have had to do a trig function. It could have been like 37 degrees, and you would have to use the sine, cosine, tangent in order to find the missing part. Okay, now we're going to talk about the area of a triangle. But before we do that, I'm going to start off with a rectangle again. You're probably wondering why I'm doing a rectangle when we're supposed to be finding the area of a triangle. So that's a good question. What I'm going to do is take this rectangle and I'm going to draw a diagonal. So I'm going to go from one corner to another. I've got a diagonal. Now if you take a look at this, I've got a triangle. Now remember, I started with a rectangle, so I know this is a right angle. And remember, I called this the base and I called this the height for the rectangle. If you look at it, look at this triangle, this one right here. That's supposed to be shading, so I shaded in that triangle right there. If you look at it, it's exactly half of the original rectangle. So the original rectangle, the area of the rectangle was the base times the height. But the triangle is half of the rectangle. So what do you think the area of the triangle would be? Well, it's the base times the height, and take half of it, so divided by 2. Or some people write it like this. They'll put 1/2 base times height. I kind of like this. This is a little bit more practical. It's a little bit easier to work with. Doesn't matter either way. It's the base times the height divided by 2. So to find the area of a triangle, that's what you do. So I'll put I'll put a little T right here for triangle, is the base times the height divided by 2, or you could write it 1/2 the base times the height. And that's the area of a triangle. So let's do an example and we'll see how it works. Now, before we do the example, this triangle is a right triangle. This formula works for any triangle. So no matter if it's a right triangle or an acute or obtuse, it doesn't make any difference. It's just right because the base and the height are perpendicular to each other. But you can have an obtuse triangle and you still have to find the base and the height, and the base and the height still have to be perpendicular. I'll show you what I mean when we do this example. All right, here we have a triangle. It's not a right triangle. It looks like it's an acute triangle, pretty ordinary looking triangle. And we want to find the area of this particular triangle. Now, I haven't given you anything, any dimensions or anything like that, but let's just talk about how we would do that. You can consider any of the sides the base. Normally, we would consider the one that it's kind of sitting on right here. We consider that the base. So if I consider this the base, so from here to here is the base of the triangle. How do I find the area? Well, it's not going to be one of these sides. So even if I knew this side and this side, that's not going to really provide the height of the triangle. Where is the height of this triangle? Well, if this is considered the base, it must be a perpendicular line from the top of the triangle all the way down to the base. So right here. It's got to be perpendicular, which means it has to be a right angle. So if they tell me this, okay, they can make it really easy and tell you what the base is and tell you what the height is. So if they tell you that this bottom right here is the base and that this top right, or this up and down part right here is the height, then it's very easy to find the area of the triangle. It's just the base times the height divided by 2. So for instance, if this is about as easy as they could get right here. Let's just make up some numbers here. I don't know, let's say that's 8, and let's say this is 4, okay? And we want to find the area of this triangle. So you use your little formula, base times height divided by 2. So it's 8 times 4 divided by 2. That's 32 divided by 2, which is 16. And it would be 16 square units, whatever it's in. Inches, feet, meters, yards, miles, whatever the case may be. And that's how you'd find the area of this triangle. Take the base, take the height, divide it by, or multiply them together, divide that by 2, and that gives you the area. It's not always going to be this easy, as you understood before. They're not always going to give you the base and the height. They may give you one, and you got to find out the other one. So let's do an example where it's a little bit more challenging than what we have right here, and we'll see how that goes. All right, here's an obtuse triangle, and they give you 3 sides, and you figure, okay, if they give me 3 sides, I should be able to figure out what the area is. Well, sometimes you need more than that, or you got to figure out. They actually, again, make this kind of easy for you, and they will tell you the height in just a second. So What are we going to do here? We got to figure out which one of these is our base, and they consider this one right here to be the base. Well, what's the height then? Is the height 15? Is the height 23? No, it can't be because it's not perpendicular to the base. Neither one of these are perpendicular to this base. So what is perpendicular to the base? Well, if we do this, if we take this, and I think we've done this in the past. If you take that, let's stretch it out to here. Let's make it a little more even, and we'll take a line from the top. So what I did is I just extended the base a little bit. All right, the 7 just goes from here to here, but I extended it out a little bit so that I can drop a line. Hate to say this, but drop a line straight down to the base or perpendicular to the base. This little blue part right here isn't really considered the base, but if I extended it out, that's where the base would be. So this blue line right here, this one right there, would be considered our height. And they actually give this to us in this problem. And that's nice because they don't always give that to you. Sometimes you got to figure it out. But on this problem, they were nice and they gave it to us and they said that's 9. So you've got 4 different numbers in here. So what you have to do is just figure out which numbers are we going to use. So remember, the area of a triangle is the base times the height divided by 2. We just have to figure out which one is the base and which one is the height. Well, the base obviously is 7, right? So we put a 7. We multiply it by the height. The height is 9. And then you divide it by 2. Don't forget to divide it by 2. A triangle, you always divide it by 2. So you multiply that out, 63 divided by 2, and I think that's 31.5, or just 31.5. Let's say this was in feet. We'll put the units here, so it's feet what? It's feet squared. Area is always squared. And that's how you'd find the area of this. Remember what this is. What are you actually finding? If I had little 1-foot square blocks, and how many would fit inside of that triangle? Well, 31.5 of them would fill this whole entire triangle without any gaps or anything. And that's how you find the area of a triangle. They could also ask you the perimeter. I want you to know the difference between perimeter and area. The perimeter is just the distance around this thing. So we don't care about the 9 because the 9 isn't really going around this. If I started here and I said, okay, walk around this whole entire figure. Well, you'd walk 23 this way, you'd walk 15 this way, and you'd walk 7 this way. And so you go 23, 15 and 7 is 22. So we're going to go 22, and that would be 45. So the perimeter would be 45. If it's in feet, you just put feet, and then you're good. That's the area, and that's the perimeter. All right, here's the last example. It's really not even that difficult. But they give you different information right here. They give you the base, right? So this 34 would be the base. This x would be the height because they're perpendicular to each other. But look what they give you. They give you what the area actually is. And that's a little unusual because usually they ask for the area, but this time they give you the area. I think it's helpful to write down our formula because that will really help us out. Remember, this is a triangle. The area of a triangle is a base times height divided by 2. What do they give us? They give us the area. So I'm going to replace that A with a 357. And then B, the base, which is 34, and times the height, which I don't know, which is x, and then divided by 2 because that's part of my formula. And now all I got to do is just solve for x. So basically I plugged everything into the formula and then solve for whatever you need to solve for. So I'm going to solve for x. You could do it a couple different ways. You could go 34 divided by 2. Let's just do it like that. 34 divided by 2 is 17. So 357 equals 17x. Divide both sides by 17 to get x by itself. And let me throw that in the calculator. 357 divided by 17, and that's 21. So x equals 21. And that would be the height right there. 34 is the base and 21 is the height. Pretty simple, I think. And that's it. So now you know how to find the area of a rectangle, any parallelogram, a triangle, and you'll be good to go for that. All right, enjoy the lesson. We'll see you next time.